The last major section on your cheat sheet is titled density, and this will be the only real number crunching that you'll have to do on your upcoming test. But before we talk about the numbers, I want to talk about the concept of density. Let's read the definition. Density is how tightly or loosely packed a substance is. How tightly or loosely packed. If the molecules of a substance are packed very tightly together, they're very dense. Whereas if the particles are further apart, like in a gas, then they're not very dense. One of the ways we're going to look at this conceptually is the ability of something to float atop or sink below a certain substance. And here's how it works. If two substances are put together, got a beaker of water here, and when they're mixed, the item floats. Don't know if we can see that in my video. Oh, there he is. He's over there. Then the item is less dense if it floats, more dense if it sinks. Some of y'all are going to equate this to mass. You're going to think like, oh, well, if it's heavier, it sinks. We're not dealing with mass. That kind of works conceptually in your brain. Density is something different. Mass is a component of density, as we'll see when we do some math here in a little bit. But if an object floats in water, then it's less dense than water. And if it sinks, it would be more dense. Now, let me throw a number at you. Let me show you what the density of water is. Water's density is 1 gram per centimeter cubed. All right? Hey, look, a unit. The cork, as you can see, is floating, right? Can you see that the cork's floating? Somebody give me an example of a density that cork might have. It's floating in water. This is water's density. Give me an example of a number, a numerical value that cork might have. What? Not 2. 2 would be too big. If it was 2, it'd be sinking. Ooh, 0.5. 0.5 would be good for the cork. What else? 0.4. Yeah, 0.4 is a good one. What else? 0.3. Yeah, don't be shy. I know it's early. Any number lower than 1. For something to float in water, it needs to have a density less than 1. But we can take this a step further. Density is an intensive property. Uh-oh, I used an old vocab word. Density is an intensive property. That means it doesn't matter how much of the substance you have, density always stays the same. It's the reason why, if you've ever been at a lake or something and you see a little twig floating down the water, and then a few minutes later you see an entire tree floating down the water, if those two items are made of the same thing, then they're both always going to float. Here's bigger cork, all right? Bigger piece of cork. What do you think it's going to do in my beaker of water? It is also going to float. Because density is intensive. Once a certain type of item will float in water, it'll always float in water no matter its size because its density will always stay the same. Let's look at a different item. All right, here's a rubber stopper. All right, what do you think the rubber stopper is going to do? Bloop. All right, there he is at the bottom. Give me an example of a density that the rubber stopper might have. 2's good. What else? 3's good. What else? 1 million, I heard. 1 million. Y'all are crazy kids. Any number bigger than 1. If it sinks, all right? Less dense floats, more dense sinks. Well, then what about the bigger rubber stopper? Yeah, he's also going to sink because its density is intensive. Size won't matter, all right? Styrofoam's another example. What do y'all think? Do y'all think styrofoam is less dense or more dense than water? How about now? It's floating, so it must be less dense than water. But again, size doesn't matter. This is way too big of a piece of styrofoam. But Hey, at least you can see it well. Do you see how I'm doing this? The last thing I want you to be able to do is calculate density. To calculate density, there's an equation that's given to you at the bottom of your cheat sheet, and it looks like this. It's density equals mass divided by volume. You'll be given situational problems where one of these variables is missing and you need to calculate it. You've done very simple stuff like this before. This is pre-algebra. But I've even made your life extra easy. If you look at the very bottom of your cheat sheet, I've given you the derived formulas that you can get from this. All right? To find volume, it's mass divided by density. To find mass, it's density times volume. Does everybody see where I'm talking about on your cheat sheet? All right? Because it's not always density that's missing. But let's go ahead and take a look at what one of these problems will look like. Trying to get this to work for my computer, people. There we go. It says, what is the density of a piece of wood that has a mass of 25 grams and a volume of 29.4 centimeters cubed? Now, you'll notice that we've got these units here that come after the numbers. You need to know what the units refer to. And that's the table that you wrote over here at the beginning. Now, we already know that grams is mass. We talked about that during this lecture. All right? Centimeters cubed, though, is something that might be new to you. Centimeters cubed is units of volume. And if you didn't know that coming into today, well, it's right here. Centimeters cubed is units of volume. And let's take a look at why that's really important. I solve these math problems in a very specific way. If you know that you are a rock star at math, then whatever. You don't have to do it my way. But if you want me to help you along the way, come back to on computer days and stuff, make sure you're doing it my way so that we can all be on the same page on the best way to tackle this. I'm going to start by pulling out the numbers with the units. The very first number that's in that problem is 25 grams. You should be writing along with me. The second value in that problem is 29.4 centimeters cubed. All right, I'm just pulling out the numbers and the units that come after the numbers. And then there's something that it wants us to find. What's this question asking for? What is the density? The next step is to identify what variables the units refer to. And that's where the table way over there can help you out if you have any issue with this. Grams is units of mass. Centimeters cubed is units of volume. All right, it's right over there if you're unsure. And now we've got all of our components, and we're ready to plug and go. So here's the equation that we're using. All right. So we're looking for density. You can keep it as a D. Some people like it to become an X to really make it feel like the way you would solve in math class. Mass over volume. Our mass was 25 divided by our volume, 29.4. With your calculator, plug and chug, 25 divided by 29.4. And I get 0.85. But don't Don't just put 0.85. That would be a naked number. All right? It's not spring break. No naked numbers. We need units for density. All right? And if you examine your density units over there, you can see what this is going to end up being. Grams per centimeters cubed. And we've solved a density problem by pulling out the numbers, identifying what they are, and plugging them into the equation. Let's do another one. This new problem says an ice cube measuring 195 centimeters cubed has a density of 0.917 grams per centimeters cubed. What is the mass? Steps are the exact same. I'm going to extract numbers with units first. The first number I see is 195 centimeters cubed. The second number I see is 0.917 grams per centimeters cubed. That's all the numbers in the problem, so I want to identify what we're trying to find. What does it say to find? Mass. It says, what is the mass? All right? Now, this equation is no good for this problem. It is. A lot of y'all know how to manipulate the variables and whatnot. But again, I've kind of simplified that by you on your cheat sheet. If you want to find mass, we'll go look at the very bottom of your cheat sheet and find the equation that says m equals, the one that's telling you what mass is. And you'll see that it says m equals dv. Do you see that? That's the equation for finding mass. But let's identify what these are. Centimeters cubed, if you look at your table, centimeters cubed is units of volume. Grams per centimeters cubed is units of density. And that step's real important. All right, if you start trying to throw numbers into places, you can get some very funky answers. And usually my multiple choice stuff will have those funky answers as choices. So be careful. So plug and chug now. All right, m equals, I like to go to x, you don't have to. Density, my density was 0.917. Times volume, my volume is 195. And multiply. I get 178.82. Grams.